Here to answer that question is Myron Mahendra from Cimco Marine. The stage is yours.
Thank you very much, Alf. Well, apologies in advance. Andreas Blomdahl, my CEO and co-founder of Simcoe, couldn't make it. He's in the US at the moment promoting Simcoe at the largest US boat show, New Orleans. So he sends his apologies. So I'm here standing to you, unfortunately speaking English. So hopefully my English is not too bad. We'll just start with Simcoe. So what do we actually do? So we're the world's first high-powered diesel outboard engine. That's what we've produced. And we're the only ones who are currently doing it. High-power definition is about 100 horsepower plus. So the question is, why diesel? Virtually all of the outboards are either 91% is gasoline and 9% is electric, but no diesel. Well, I think we use this as an analogy. First of all, on the road, you'll find that all trucks, commercial trucks, pretty much run on diesel engine, right? Diesel fuel. You'll find power generators that run on diesel. Why is that? Well, partly because diesel engines themselves are quite robust. They're heavy, but they're robust. They're durable. They last a long time, and they have a lot of torque. And that means that you could push load very heavily at a very low RPM, and that's great for commercial users who are carrying a lot of heavy stuff for lots of people. For example, it's also not combustible. In other words, gasoline is highly combustible from a health and safety perspective. It's not great to carry a lot of gasoline on board. So why haven't they actually done it for the outboard, for example? Because if you look at the inboard marine application, inboards were introduced in the 1960s. Now, currently, 99% of inboards are all run on diesel fuel, 1% gasoline. And again, that implies that there is a strong demand for diesel, but for some reason, for the outboards, no one's prepared to come up with it. And I will explain why. Well, let me just sort of give you sort of a summary of Simcoe Marine. We're the first to produce the 200 horsepower diesel outboard engine. It's a patented belt-driven system, so it has key technologies. Is the belt propulsor unit. It runs using an automotive engine, which sits horizontally mounted, and it has a hydraulic clutch gear system similar to a sort of car, automatic engine. We started production in 2016. We've now opened up our number of engines available from 125 horsepower up until 200 at the minute. We also listed successfully on the First North Stock Exchange with the help of Västra, Hamnen, anordnat, and Avanza. We've also introduced the 150 horsepower in January of this year. And we also, this month, signed up with BMW for them to supply their 3-liter 6-cylinder twin-turbo engine to produce 300 horsepower. So we've now got a range effectively from 125 horsepower up to 300 in 2020. So let's just look at the conventional outboard for starters. I think this is a good comparison, right? So you can see that the engine here typically sits vertically, with the and you can see the crankshaft coming straight down to this very small little gear, dog clutch bevel gears that then propels the propeller, so to speak. And when it first came out in 1920s, it was fine because its horsepower was like 5 or 10 horsepower. But when you start going above 100 horsepower, this becomes a real difficulty. This becomes a bottleneck in terms of production. Now you see engines running from 100 horsepower to about 500 horsepower now. But these are gasoline engines, and they've tried many times to try and use diesel. But the problem is that the diesel engine produces a lot of torque, and having this gearbox, which is the size of a tennis ball, it's just going to explode. It's just not going to work. So we had to find alternatives how this could work. And of course, this particular engine here is bespoke. It's only for the outboard. It only works in the outboard. You can't apply it for any other purposes. And so it becomes very expensive to develop a brand new engine, even to meet emission levels that the automotive industry has. For example, the automotive industry, of course, sells millions and millions of cars. But for the conventional outboard, we probably sell 1 million at most a year. So they've got special dispensation to not meet the emission levels, say, as an inboard, for example. They can pollute 3 times as much as a typical inboard would look like. And in fact, let's say you take the Yamaha 200 horsepower, the brand new engine that is looks good, doesn't smoke so much, but in fact, it produces as much pollution as a car of the 1970s, for example. So it's actually pretty bad. Having said that, the question, of course, is why have they been granted this dispensation? Well, you've got two manufacturers in the world, which controls 80% of the market, which is Yamaha and Brunswick. And they have a very strong lobbying group in the US, and they've managed to somehow convince them that if they were forced to meet emission levels similar to that of the car industry, they will just stop producing. So they're pretty much led by these two in some extent. So how can we improve on this, and how can we bring in diesel then? Well, what we've done is to say, well, let's just take a car engine, right? Because car engine, if you put it vertically, it'll just work for 2 minutes and it'll just stop. But if you use it as it should do, and sitting it horizontally, and what we do is then power it, rather than have a crankshaft coming out, we replace it with the belt, coming down to a very large gearbox, in fact. And that gearbox sits above the waterline. This is the other critical thing, just going back. If we increase the size of this, of course, then what happens is the drag gets worse and worse. In fact, you can't actually drive the boat any longer because it's just too big. So in this case, we've got our gearbox, which is an industrial gearbox, multi-friction plate gearbox. It sits above the waterline. You can make it as big as you want. And so therefore, you can cope with the amount of torque that goes on into the gearbox, the amount of power going into that gearbox. And that gearbox then drives the propeller shaft with another belt. And in fact, we can actually reduce the size of that torpedo if we wanted to make it even smaller and make it more efficient. Now, the reason why we kept it the same size at the moment is because the propeller manufacturers produce similar size for the entire industry. But in due course, as our product becomes more mature, we'll be able to do more things with the prop. So what does this do then? Well, we then can bring in a diesel engine. We could use actually any engine. We could use a gasoline engine, but we said we'll use a diesel engine. It's more fuel efficient. And of course, that means that you've got the emission levels that the automotive industry has been matching all this time. And that, as a result, produces 45% less carbon dioxide than the conventional output would look like, which means, of course, very fuel efficient. But of course, with diesel engines, it's heavier, it's more robust. So for an equivalent, it's about 350 kilos for this product, compared to, say, a 200 Yamaha, which is about 275 kilos. But the weight ratio in terms of that compared to the fuel emissions efficiency is remarkable. And of course, we can do a lot of other things that comes out of it. The trolling mode, which means you can go down to 1 RPM, you can crash stop without breaking the engine. And if something did happen, if it crashes into a rock, you can always replace the lower leg. Whereas for the conventional, you'd have to replace the entire product in itself. So if you look at the breakdown of the engine, actually, we're not reinventing the wheel here. I mean, what we're saying is that we're taking best-in-class systems and just putting it together. It's a modular system. We're taking, in this case, a GM engine that sold 5 million units. We know it's rock solid. It works. We've taken a belt, these two belts, the primary belt and the secondary belt, from Gates, which produces carbon fiber belt for industrial use. So we just take it off the shelf. We know it works. The gearbox, the concept, we know it works in cars, so that's not an issue. So basically, we put things together and we said, let's try and patent this, and that's what we've done to some extent. So a lot of these things, we know it works separately, so that's why we know over time the product will actually work in its various components. So why is Cimco a success? Well, I think partly because of the patents now that we've developed. It's US, EU patents for over 25 years. And of course, as the concept becomes more acceptable, because it looks like an outboard, but it's nothing like it. But nonetheless, if the concept becomes more acceptable, we could actually license it out to other manufacturers as well. As I guess, with no competition in place, for us, we can keep on expanding our range in sort of good time. Of course, we've also got the demand, strong order book from our distributors. And more importantly, we've also outsourced production and sales. So rather than actually having it in-house, we've used specialists in producing our engines or assembling it together. And we've used sales with distributors who have a very strong presence in their regions. That makes us very agile and focused in innovation and in development of our product range. And of course, the last point is the legislation. There's more legislations coming through, particularly in rivers and coastal lines in the US and North America, but also now in China as well, where they want to reduce emission levels. Of course, the single fuel directive was the main driver for us, and that's because back in 1995, a US Navy boat exploded. They were carrying a lot of gasoline for the outboard. And they came up with a direct, they said, look, if you can find a product that sells diesel, a diesel outboard in this case, then you should use it. And that's also a key driver for us in terms of developing the diesel outboard. Now, the product, as you can see here, in terms of fuel consumption, is extremely good compared to the gasoline compatibles. And of course, the range is far longer as well. Now, one of the you can see here in the graph below here that for commercial users, your break even, because we cost about 2.5 times more than a gasoline equivalent. But then for the lifetime use, you'll see that we've actually breaking even at 500 hours. In other words, after 500 hours, taking into account the fuel consumption, taking into account the servicing, you start to break even compared to a gasoline equivalent because it lasts 3 times as long. You'll have to replace the gasoline engine at some point, much sooner than the diesel, for example. One example I'd give you is Hurtigruten, which is a cruise liner, Norwegian cruise liner. They use polar expeditions, and they use tender boats to take their customers out to look at wildlife or to look at various islands and so on and so forth. And when they first, they used 15 of our units. When they first experienced it, they were impressed because normally when they take out their customers during the day, using a gasoline outboard, they'll have to come back at lunchtime to refuel, have lunch, and go back out again. With our product, they were out all day. That meant that they could have a much more fulfilling itinerary program with their customers. Their customers were much happier. They could charge more to their customers, of course. But they came back with still a half fuel of tank in it. So the second point, of course, was that they've developed 2 new cruise liners. And typically, if you have to store gasoline, you'll have to have safety measures in place because it's quite combustible. So you have to have stronger storage facilities and also have the ability to dump the fuel if the boat catches fire, for example. That costs a couple of million euros to do that. With the 2 new cruise liners they've developed, they've got no gasoline storage facilities because they're using our product now. So there's huge benefits. Giving an example of a commercial user using the oxy-diesel. And this is the evolution of the oxy over time. It was actually first developed by Jill Marine in 1995 together with Volvo Penta. Volvo Penta decided not to continue with that. And Marine Diesel Sweden, who Andreas is the owner of, took over that concept to try and develop it further. And what had happened, of course, he discovered that, of course, automotive diesel engines became lighter and smaller. So that made it more effective to say, well, let's use that as an outboard. And of course, the financial partner, Cimco Private Equity, that's where I came in. I was the CFO of Cimco, and Andreas approached us. He sort of drew up the concept in a piece of paper, and I thought, it's really interesting, this. But I said, can a bunch of engineers from little town Ängelholm do this? I was a bit skeptical, but I was impressed. They actually did it. Not only did that, I was so impressed, I joined them as well. So it's been a long journey for us, and I think we'll continue to revolutionize the marine market without a doubt. And these are some of our end customers. You've got pretty much hard-wearing customers who, for example, the fishing industry, they carry heavy loads, for example, taxi boats, lots of passengers, all the offshore oil. That's because of health and safety. They can't use gasoline. Research expeditions, polar cruises. And of course, governmental, you've got the coast guards, rescue boats, police, military defense, all of them. And of course, our addressable market in that, we believe it's around 77,000. And of course, this is the single fuel directive, which I mentioned to you. So it's pretty much the governmental force said we want to have diesel fuel simply because it's more efficient, it's safety perspective, it's non-explosive. The US Coast Guard has been working on our twin engines for some time now. Of course, we've got the US Navy research, they're working on that as well. And in fact, they've also asked us to send them a prototype of our 300 horsepower BMW engine to them in sort of February next year for them to test it out as well. And also the Chinese Navy in the Far East are very keen on us as well. So they've been testing it out. And of course, like I said to you, there was an exemption for outboard gasoline engines in terms of emissions. They didn't have to be approved by anyone. But because we were diesel, we had no choice but to do it. And so we were the first outboard to ever get certification, Tier 3, from the EPA, which is fantastic news. And this is a pattern which is actually fascinating because it's very wide. And this is what amazes people, because they said, look, what this pattern says is that we've got a horizontal engine that powers the gearbox using any means, whether it's a belt or a chain. And that power is then delivered from the gearbox down to the prop shaft through, again, any means. And that's essentially as wide-ranging as you possibly could get. It's very difficult to get around this, if you want to develop a brand new, outboard or concept, because it's very difficult to do that. So I think that's one of our key strengths of Cimco is its patents and the ability then hopefully to license this out in the future. Our business model, we like to keep it simple and straightforward. We want to focus just on R&D and innovation. We like to get our production outsourced, in this case to UFAB, to assemble the engines, and of course to our distributors who take on board buying our products and selling it to the end customers, so to speak. And this is our market overview. As you can see, 91% of inboards are gasoline, 9%. Inboards are gasoline, 9% is outboards. Diesel, sorry. Of course, you can see the market share here. Yamaha and Brunswick pretty much controls 80% of the market. Our market share is 100 horsepower and more. And as you can see that there's no diesel outboards in this case yet. And of course, this is our distribution network so far. We're hopefully building more in South America and more of Europe as well in due course. But we've got some very strong distributors who will support us in the coming years. And so far, this is sort of the minimum order book which we've got from them, 1,000 engines. Our production, as I said to you, we've sort of shipped it out to UFAB to develop it out for us. This is a video of them for playing it.
For assembly of the OXE, Cimco Marine is collaborating with UFAB. With its roots in shipbuilding industry and as one of Sweden's foremost OEM suppliers and contract manufacturers of advanced components and machinery systems, UFAB offered the perfect assembly location. In collaboration with UFAB, we have developed an intuitive production process. At this station, we are completing the marinization of the engine. The powerhead is an automotive engine mounted horizontally, just like in cars. The horizontal design enables fluids to be evenly distributed throughout the engine, reducing wear. This also makes it easy to work with for technicians with an automotive background. Here we assemble the primary belt. It protects the engine from harm if the propeller becomes fouled and seized. A clever feature is that the user has the option to decide whether they want torque or speed just by turning the unit. Parts below the waterline, just bearings, a shaft and the belt coming down from the gearbox. Above the waterline there is a different story. The gearboxes are built with a heavy-duty design to withstand the transfer of torque from the diesel engine to the propeller. It is developed and built with commercial users' demand in mind. At this station, the whole unit is assembled. The modular design is brought together with heavy-duty bushings and bolting. The OXE is built to last. For us, the end user is always foremost in mind. Endurance, reliability, power and control are our core values. At this station, we test the engines according to an extensive test protocol. Everything is monitored and stored. When testing, it is a huge advantage that the engines run on diesel. Due to this, our work environment and safety improve significantly. Before we fit the cowling, we go through the checklists upon final inspection. Everything is documented and stored. To create an outboard able to withstand commercial cycles, we had to rethink everything. We believe the end product looks amazing. The outside really reflects the inside. The OXE is built for unforgiving conditions. We ship the engines from here all over the world. It is amazing to think that these engines, built here by us, are now in all oceans of the world, providing commercial users with the engines that are up for the task, whatever they might be.
So that was just a short video, hopefully made it more interesting than, sorry, me just rattling away. Competitors, we don't really have any competitors as such yet. Brunswick are producing a gasoline engine that runs on diesel, very inefficient. In fact, it actually consumes more diesel than it did in the gasoline form. And it's spark ignited, which is not particularly great either. Cox is currently developing a diesel outboard engine, 300 horsepower, but it's using it vertically. Now, you remember, it still has the issue with the lower leg. You know, how is it going to transmit all that torque down to this small gearbox sitting below the waterline? So I'm not entirely sure whether it will succeed. They're spending tens of millions of euros at the moment developing their own production facility, developing their own sales, for example. So I'm not quite sure. That's what they're doing is doing it the right way. Neander Shark, well, it's out in the market at the moment. It's producing 50 horsepower. Like I said, below 100 horsepower, you don't really need to have a diesel outboard. And I think theirs is just too heavy and it's more expensive than our product, which doesn't really make any sense. But so far as I'm aware, they haven't really sold anything just yet. So they're trying their best. But I think they need to bring the price down, I think, to make it work. Cordwell, converted inboard, yeah, unfortunately the founder passed away quite recently, so they're not going to continue any longer. Yamaha, we've no idea, and certainly we've not had any gossip about them developing a diesel engine. I think they're going to try and do hybrids if they can, but I think they're still focusing on gasoline, or developing further more efficient gasoline engines. And of course, the next generation, all our customers are wanting bigger, more powerful engines. And BMW have been in the marine industry for some time. They produce, they supply their engines for inboard use. So they approached to say, look, we would want to develop their 6-cylinder, 3-liter twin-turbo engine. It produces virtually 328 horsepower at the crankshaft. But of course, we calculate the horsepower at the prop shaft, so there is a loss of power. So it will be about 300 horsepower once we finalize it. And this can be, obviously, we can detune it to 200 horsepower to make it a really rock solid. But our focus is 300 horsepower for the minute. It's very fuel efficient, and it's actually lighter. It's just as light as our Opel 2-liter. So that's pretty amazing from the technology perspective. The Opel engine is about 13 years old, and this is pretty much brand new. So you can see the automotive industry have been really sort of focused on bringing it more efficient. They've got the capacity to do that, and we're just building on that. I mean, the cost of R&D per engine is actually tiny, and the cost of the product is pretty much similar to the Opel now. So it's a win-win for us from that perspective. And I thought I'll play this video, which gives a little bit of history and also about the evolution of the Ox going forward.
workshop, the development work of the Oxy 200 started some 5 years ago. The product has been in the market for more than 2 years now, and the reception amongst our customers has been very good. The customers, though, still ask for higher output. And now we're developing the new generation diesel-powered outboard with a 6-cylinder twin-turbo 3-liter diesel engine as a basis. Therefore, Cimco has initiated the Bison project, where the target is to deliver a new product with increased engine output, reduced fuel consumption, reduced weight, and reduced need for service. One of the challenges in the project has been to combine these requirements with the current and common legislation for emissions. Therefore, we have focused on one of the most modern engine family from the automotive industry. The engine family that we're working with in the Bison project ranges from 3 to 6 cylinders in line, all cast in aluminum. Another focus point in the project has been to increase the time between overhaul even further, allowing our customers to spend more time on the water. This has been a challenge. We have had to rethink under cold conditions, thermal management, and details in the transmission system. The Bison project has now reached that far that we're soon ready for the startup of the first prototype. The prototype is visible here. The complete outboard engine has never been started before. Each subsystem has been tested and approved, and now the electricians are connecting the last wires for the engine control system.
My name is Andreas Blomdahl. I've been CEO of Cimco since June this year. I've been on the board of directors since the company was founded in 2012. I'm one of the original founders of the company. People normally bring up when you have presentations is the question on emissions, specifically now with all this Volkswagen gate and diesels are terrible and not environmentally friendly. But when you look at the marine side, it's quite the opposite, or the least environmentally friendly products you can actually buy on the market today is either a gasoline lawnmower or a gasoline outboard. If you buy a brand new 2018 gasoline outboard, it's about the same emissions level as we had on cars back in the 1970s. When it comes to diesel outboards, there is no emission regulation, so the diesel outboards step into the same emission regulations as inboards, and it's a much stricter controlled area. Well, the main characteristics that makes the OXE unique is that it's a diesel outboard. There are no other diesel outboards in the segment. Technology-wise, it's very different to all other outboards on the market. It looks like a regular outboard, it runs like a regular outboard, it fits the boat like a regular outboard, but underneath the shell it's very different. It's a horizontal engine, it's got a much larger gearbox placed between the engine and the propeller shaft, and the drive system between the engine and the gearbox and the propeller shaft is a carbon fiber belt system.
In the Bison project, we have inherited a lot of the design features from the old Oxy engine. Here in front of the engine, you can see one of the features. It's the air filter, and the seawater filter, and the fuel filter. Back here, you can see the seawater pump. And on the back of the engine, you have the oil filter, easy accessible. All the service points are easy accessible from the back of the boat. Maintenance is easy. We believe that if it's difficult to maintain, the user may skip it and risk failure.
Now we're ready to start up the engine. Everything is controlled, all systems are checked, and we are going to give the start signal to the operator.
Well, I think that's pretty much it. Thank you for your attention and your time.
Thank you. Thank you, Myron. That was very interesting. We have a few minutes for questions, if anybody has any.
Yeah, I think for us, it's being a young company, you're having to develop the product from a standing start, from a development company into a production company. That always takes time in terms of moving from prototyping into a production style supply chain. And we've always had problems as we went along, and we had numerous problems, in fact, and we've narrowed down to one or two. And over the summer, it's predominantly been the castings where we had issues with, and very high rate of failure by the manufacturer. And so the solution for that was to dual source, to find another supplier to meet that. And of late, we've appointed another supplier who will be supplying us from December onwards. Our target is 25 units a week, and that's because with the 200 horsepower, a gross margin be very positive, and we want to keep that steady as we go along. And I think we hope that this will keep us going and also improve in terms of the cost down, because we are looking to also improve our supply chain by giving higher volumes to our suppliers who can produce those volumes for us, but also reducing the cost base. So we have been producing around 18 to 20 units a week. So we're getting close to 25. So the aim is by December onwards, we'll try and hit 25 a week at that point. So it's been a challenge, it has to be said. But I think it's not unusual for companies of our size to go through this process from moving from a development prototype company through to a production in high volume sort of company.
Thank you. Any other questions? I think I'll just jump in with a question myself. I was thinking, still on the question of the environment. Of course, diesel engines, you've shown that you're a lot better than what's out there already. The next step, you might suspect, would be electric engines, because from the car market, we know that they can be really powerful now. Could that happen in the outboard market as well? And if so, would that be competition to you, or would you just adapt to that standard?
Well, I think that's an very interesting question. In fact, the outboard market, you'll probably see that there are electric outboards out there, but it's actually for very low powered, partly because of the battery capacity. I mean, you've always got to look at how much battery you've got that can store the energy to propulse the unit. But for the high-powered units, it's trickier at the moment, because if you're running our engine, a 200 Opel engine, at wide open throttle, using a Tesla battery, it'll last 8 minutes. So you haven't got much capacity there. So for the battery, it needs to improve in terms of the technology for that. But you could use hybrids. So potentially you could use in port or in rivers. You could have a combination of battery as well as engines later on in terms of a hybrid version of it. But again, if you think about the torque, right? You have huge amount of torque available in battery or electric cars at 0 RPM. So our concept actually works very well for the battery aspect of it. So I can imagine, again, rather than using the conventional, you would actually use our sort of concept to power using electric mode, definitely. Certainly for the high-powered range, that would make sense. So we think that this will be adopted over time once the battery technology improves, of course. But for very, very large vessels, you're talking about the huge shipping container vessels, electric actually makes sense, because once they get on plane, steady state, and they can store a lot of batteries on their hull. So that would make sense, I think, for the industry. But for our range between 100 and 500 horsepower, it's at the moment the technology isn't available. Yeah.
And you didn't quite say it, but I understood your description of your patents as meaning that you could, in principle, put in any engine.
Correct.
So if you were to put in your patents don't specify diesel engine.
Correct.
It could be,
yes,
right,
it could be gasoline, it could be electric, it could be any form of energy. Yeah.
Okay, great. One final question. No, otherwise it's time for a break.